All right, so this is 11.6. We are doing the area of regular polygons. So earlier on in the chapter, we dealt with areas of figures like triangles, quadrilaterals, rhombuses, kites, parallelograms, rectangles, squares, things like that, trapezoids. So what we're doing now is we're talking about things that have more than four sides and how we're going to find the area of them. Now, keep in mind, everything that we're talking about here is regular, which means all of the sides and all of the angles are the same. So what you see here in this diagram is you see a diagram that has a circle around it. Now we're going to use the circle for purposes of you understanding that a circle can always be drawn around a regular polygon. So we have a circle, and our regular polygon here has 6 sides. It's a hexagon. And it says the diagram shown shows a regular polygon inscribed in a circle. The center of the polygon, okay, that's the center, just like it would be for the circle, okay, is C. And the radius is going to be the radius of the circle. So notice how all of our vertices of our polygon is just right on the edge of the circle. So if I were to draw from the center to the vertices, and I could do that all the way around, that is the radius of the circle. Okay, and that's important for you to know how to do that, or for you to be able to do that and know what that means. Okay, so now it says the distance, the next part, the distance from the center to any side of the polygon is called the apothem. That's this A right here. Okay, so this A right here, that's the distance. Why is that the distance to the side of the polygon? Notice how we're going straight down. From the middle straight down. If we were going from here, it'd be from the middle straight down. It's got to be straight down that it creates a perpendicular, because that's the smallest distance that we want. And then the third thing, the central angle, that is this part right here. That's the central angle of a regular polygon, is any angle formed by 2 radii drawn. So notice radius here forms an angle. Radius here forms an angle here. Okay, radius here forms an angle here. 2 radiuses, angle. 2 radiuses, angle, 2 radiuses. Those are all central angles. And to find the measure of each of those angles, we would take the number of sides, or number of angles, and we would divide it by 360, because there's 360 total degrees. Okay? So it's very important for you to know those 3 things we need. We need to know an apothem, we need to know the radius, and we need to know the central angle, because when we want to find the area, we use this formula. We use 1/2 times A times P, where A is the area, the capital A is the area, the small a is the apothem, the distance or length of the apothem, and P is the perimeter. So that means the sides. So we either need to know the apothem and one of the sides, or our other formula can be 1/2 times the apothem and then times N and S. N will equal the number of sides, and S is equal to the length of each side. Now, that's the same thing as the perimeter. Okay? So we need to know the apothem and we need to know the sides. Now, the radius can be important, and it may come important in a minute. So let's talk about how this works. And you want to be able to write these down. I'm going to go through these pretty quickly, but if you want to pause the video and copy them down, you can. So if you're missing anything, so obviously we need the apothem and we need the length of a side. But if you're missing any of these things, these are the 3 things most likely that you're going to use to find them. You can use the triangle angle sum. So if you're missing an angle, then you might want to do that. Okay? If you want to find a missing side, then you could use the Pythagorean theorem. And you also might be using trig ratios based on what our angles are. So those 3 things can be used to find any of our missing items that we need for this formula. Okay, another thing that you want to note here is 2 things, is that the apothem is the angle bisector of the central angle. Okay, so the apothem does cut this into 2 equal angles. So if this angle was 80 degrees, the apothem would cut it into 2 40-degree angles. Also, the apothem not only creates a right angle when you come down to the edge, but it also bisects these two, this triangle. So that means that this side would be congruent to this side. So that's actually important for what we're going to do. So let's look at a couple of examples here. and hopefully this will make sense. So let's get to it. So we're looking at an example here. We're given this triangle, and we're given limited amount of information. So we want to be able to find everything that's missing here. So the first thing we're looking for is the measure of angle AFE. Okay, well, AFE, if you look at this, AFE is a central angle. So we should be able to find that fairly easily because we just said, to find the measure of a central angle, we know there's going to be 5 of them. So we would simply take the number of sides, there's 5 sides, and we would divide 360 divided by 5. So 360 divided by 5 is equal to 72 degrees. So therefore, we know that this angle right here is 72 degrees. Okay, that's the first thing. The second thing, we want to figure out what FG is. Well, FG we don't know, but we do know that we have a right triangle here, and we also have a side. The problem is we only have one side, which is this radius right here. So if we only have one side, and we don't have a second side, we can't use the Pythagorean theorem. Well, because we only have one of the angles, we can't use the angle sum theorem, so we're going to have to use trig to figure out what FG is. So we know that this entire angle right here is 72 degrees. So because we know that the apothem here cuts it in half, we can figure out that this angle, the smaller angle of the triangle, is going to be cut in half. So this angle right here is going to be 36 degrees. Okay, I got that by doing 72 divided by 2. So that's 36 degrees. So we're going to use trig to figure out what this missing side is. So what we do is we have the 36 degrees. We have the 8. The 8 is the hypotenuse. The FG is your adjacent because it's right next to the angle. So because we have an adjacent and hypotenuse, that means we're going to use cosine. So the cosine of 36 degrees equals FG, which is our missing, over 8. Multiply 8 on both sides, put that into a calculator, and we get that FG is equal to approximately 6.5 meters. So that's the second part. So now we know that FG is 6.5. That's our apothem. Okay? Now we need to know what GE is. Well, GE can now be used. We know our FG. We know our FE. So we can use the Pythagorean theorem to figure out GE. Now keep in mind, the reason why we're doing these, we're going step by step because that's what's going to have to be used to figure out the area of this entire figure. So now, once I know what GE is, I'll be able to figure out what one of my sides are, which means I can figure out what my perimeter is, and then I can already have my apothem to be able to figure out the area. So let's go through this. GE is going to be using the Pythagorean theorem. So 8 is our hypotenuse. So we have 8 squared equals 6.5 squared plus, and then our missing side is our x squared. And we're going to call this x. So we do the math there, and we get 64 equals 42.25 plus x squared. So then we subtract 42.25 from both sides, and we get 21.75 equals x squared. Take the square root of both sides, and we get x equals 4.66 meters. So that is actually what GE is equal to. So that's the answer to this question right here. Now, to figure out the area, we need the entire side. So we have half of the side. Remember, this is a bisector. So we take our 4.66. So AE is going to be equal to 4.66 times 2. Okay, which is going to be 9.32. So now we have one of our sides. Now, to figure out the perimeter, the P will be 9.32 times the number of sides, 5. So 9.32 times 5, okay? That'll be the perimeter. And then we're just going to use our formula. So it'll be 1/2 times A times P, which is equal to 1/2 times our apothem, which is this right here, that's our FG. This right here is our apothem. So that is 6.5, and then times 9.32 times 5. Remember, this has to be the perimeter. Okay, perimeter is 9.32 because that's one of the sides multiplied by the number of sides that there are. And again, just put that right into a calculator, and we get that our area is 151.45 meters squared. And again, that is a long process, and that's a little bit of a more complicated problem because everything was missing. But if everything's given to you, if your apothem and your perimeter or your apothem and side is given to you, then it's a lot easier to find the area. But sometimes it will take a few steps for you to find everything that you're missing. So that's a broad overview. You may not understand everything. That's okay. Don't forget to take your Edmodo quiz if that's been assigned, and I'll see you in class and bring questions there.